Continental and continental convergence involves, as you can guess, two pieces of continental crust slamming into each other. When continental and oceanic crust run into each other, when they converge, the heavier, denser oceanic crust subducts, it slides under the lighter, less dense continental crust. However, when two continental plates run into each other, because they are of similar density, the movement is up rather than down. In other words, no subducting, the plates are going to rise. And nowhere does that happen like it happens between India and Asia. If you take a look at this diagram, remember I told you this before, look at where India is when I showed you the map of Pangaea and it breaking apart. India was out in the ocean. Well, you can see with this map that 70 million years ago, India was out in the middle of the Indian Ocean. Then it began to move north and turned a little bit. And it continued to move north. And then today, it's slamming into the Eurasian plate. India is what we call in this business a subcontinent. It looks like it's part of Asia, but geologically, India is a completely different piece of crust than Asia. They're both continental crusts, but they are not connected together other than through a collision. The result of that collision is the Himalayas, the biggest mountain range on Earth, the highest mountain range on Earth. You know, these mountains reach nearly 30,000 feet. So in Southern California, the mountains are almost 3 times smaller. This picture is from the foothills of the Himalayas, which you can see in the foreground. Then you can see these monster mountains in the background. If you look at this diagram, you can see the yellow arrows are indicating India moving north, and I've circled the Himalayas. Just to the north of that, you can see the Tibetan Plateau. The Tibetan Plateau, which is all uplifted because India is slamming into Asia, has land that the flatland is 12,000 feet above sea level. The lowlands are 12,000 feet up. So you can see what's happening as this continent runs into the other continent. There's massive uplift. Many people have thought, well, what happens if India continues to go north? Are the Himalayas going to be 30,000, then 50,000, then 500,000 feet high? The answer to that is no. And the reason is that wacky term down below, isostasy. Isostasy is the flexibility of the crust. If you deform the crust quickly, it cracks. However, if you deform the crust slowly, the crust is actually very flexible. Imagine, let's take a look back, how much these mountains must weigh. Wow. Well, it's a vast amount. And that incredible amount of weight presses down on the crust and then into the top layers of the mantle, which are somewhat flexible anyway. And the result of that is that the mountains cannot continue to grow indefinitely. At some point, they reach a place where they weigh so much that they're pressing down on the crust, and the result of that is that they will no longer rise. This is Tibetan Plateau. That's the Flatlands, 12,000 feet above sea level. I took this picture in a July. Notice what the kids are wearing. Does that seem like July weather to you? It's because once you start getting 12, 13, 14,000 feet up, I don't care where you are on the planet, it's going to be cold. And it's chilly there, especially at night. Let's take one more look here at the tectonic plates. Get a good look at this as a kind of recap. You can see the Pacific plate in the middle, the Juan de Fuca plate, the Cocos plate, the Nazca plate, the South America plate, the Caribbean plate, the North America plate. Then look over to the left. You can see the Indian plate and how it's running into the Eurasian plate. Get a good look at that.